x plus d. So you can see the common term they have is this x actually come from the previous this equation. So you will solve this using integration method where we actually will integrate the both sides. So when you integrate both sides, first thing you need to do is dx will be remain at the left hand side and the rest will be bracket. You will put like this x plus bu and then the dt will be moved here. So dt like this. Then you integrate both sides, you'll be having ax plus bu, then dt. Then you solve as usual, you'll be having this become your x equivalent to integration of ax plus bu, then dt. So you have learned how to draw this block, sketch this block diagram. So if you have x and this is equal, then you'll be having the one at the back here. So let's say I'm using the one because they will continue with this one. So I won't put a scope over here. So I will just draw an arrow here. Arrow means equal, equal x. So arrow means equal. So this one will be your x. Then you'll be having integrator 1 over the s. So this one is integrator. So you will start from the back. So when you read this one will come first. And then the add block. So this one is the add block. You'll be having the add block and plus, plus. So this one is plus, this one is plus. And just put plus, plus over here. So you will having b multiplied with the u. So as indicated in the question over here, your u is actually the input. Okay. And then your y is the output. And v also one of the input, but it is disturbance. And the disturbance over here, it is 0. Okay, the v is 0. So this one is disturbance. The x, okay, the x over here is the input. Okay, sorry. The x over here is a dependent variable, which means your output for the first part. And then you have the output for the second part as your b. So this u over here is the input. So when you have this, you will sketch. Okay, now your input, it is your u. So u is the input. First part, this one u. This one is the input. Meaning that you have b multiplied with the input. Means the b must be in gain, because multiplication, you must use the gain. So from here, you can put your like this. Okay, and then the b is the gain. So if you check the gain over here, the gain will be having input and output. So you cannot put this gain at the first one. It must be in between, because you're having the in and out from this gain block. So from here, here is your u. And they will tell you what is the this example. So the u here, there are 5 types. Okay, so they choose the constant input and also constant input. So for this v is the disturbance, and this u is the input, and the one that choose the type of the input is constant. So from here, your input, the constant is just like a box, then you just name this block. So during a test, the same thing, just name the block constant, and this is the block of the gain, this is the block of the add. Okay, so you have ax here. So means a multiplied with the x. And you have this whole line x going back. Then you multiply with the a, means the a must be actually a gain block. Then go into here. So this is your ax. So this whole line is ax. So this explains why they're having this. So we actually do the similar solution where we actually integrate both sides. Then we do from the back. For example, you move this x to the back, it is the equal line, like this one. And then you will start with the integrator block, this one. So you put it here, and you have the ax plus b. So this is the add block. So I put the add block here. So the bu is the input. So u should come first. and U is the type of constant input, and B stand for multiplied with the U. So gain, you must put the B, the gain block. Same goes to AX. Your X come from your output, which is from here. So you are actually having this X go back to here, and this is a multiplication. A multiplied with the X. So you'll be having a gain block over here. Okay, so this is the block we have. Okay, then we will continue with the second part, which is Cx plus D equals to Y. So you look at the equal over here, meaning that if you extend here, you're having the endpoint, actually, it is your Y, because equal Y. So your endpoint is equal Y. Okay, and then maybe you use the one, okay, they are using the scope. So here, you just put scope. In your test sufficient. You don't need to draw something like exactly the same, the how it looks like. Okay, maybe very simple for this. Just put a box inside to represent the scope. Okay, so we already done Y equal. So this one done, which is actually using this. Then we have the Cx plus D. You already have your X here, and C stand for multiply again. And you will need to actually continue with the gain block. So you'll be having the C over here. So you'll be having Cx off. So this one is Cx. And you plus D what? You having the Cx plus dV. Okay? dV. Okay. And they say V, it is disturbance. And multiplied with the D. So you'll be having this addition, right? So you'll be having addition. So this one will be the add block. So plus, C go in here, plus, and this one go in will be D and V. So V is the disturbance. Disturbance will be at the first, come before the D. So meaning that you'll be having this one. So this one too small, I will draw it bigger. So just now I have this scope. Then go inside, here is my Y, represent Y equal. Then Cx plus D means I must be having an add block over here. So plus. So I'm having Cx. So Cx, I already have the C over here already. So Cx means multiply. Multiply means I must having the multiply means the C must be in the gain block already done. So this one go in here. Then I'll be having Cx plus dV. So go inside, you'll be having a gain of this one, you'll be having dV. So the dV, the D will be the gain because multiplication again, and V is the disturbance. So disturbance is like one of the input. Input should actually come here. And they say this V also is a constant. So you will just name this V constant here, name the block. And this one is multiplication with the D, so it's a D. Okay, so these two plus together become this. So you will sketch this during your test and also during your final exam, because we do not have the Simulink software given to you during your test and final. So you are going to sketch the block. If let's say I include some numbers, I ask you to represent using the Simulink blocks, you're able to actually sketch in this form. Okay, so later you will actually, depends on the numbers given like this, they just want to explain to you, if let's say these are the equations given to you, can you actually transfer into the form of the blocks? Okay, so this is the way how we do. We will integrate the both sides, then we will finish the first part, and then we will check, okay, this is the X. X is here, so you continue from here, multiply with the C, because CX. Then you have the addition block over here, so VD. So it is D first or V first, you have to check which one is input. Like V is the input over here. So this V is the input. That's why V should place at the first one. And when they put this one missing, D, V. So this one means multiply. Multiply means you have to include the gain block. So that's why I put my D here. It is because my V is disturbance. So disturbance input all should place at the first one. Then go in, so dV plus Cx, because x is here, so dV plus Cx equivalent to your y. Okay, so this is the solution we have for this one. So we combine everything, we will get this block. Where's my mouse? Okay, we will get this. So this is exactly the same solution that we have. Okay, so sometimes you will see the gain, right? They prefer to put at the bottom, meaning that go back here, then like this, the A, then only go up, go in. So this one is the same one because you already have your X here, meaning that this one go inside, it is AX, like this. Either you want to place your gain in this direction, or you can put at the bottom because this is a whole line. It doesn't matter, you want to put it here also fine, here also fine, here also fine, or you want to put it here also fine. The same answer actually. Either you put like this, then if you're using the Simulink, right, you have to right click and change flip. You have to flip the block. Okay, so this one done. Okay, then there will be numbers given to you. What are the A, what are the B, C, D, B, and U? Then you will complete the diagram. Like for example, the A is 3. Then instead of just having the A over here, I will just put in your solution of test, right? I will put A equals to 3. And then U equals to 1.5. I'll put equal 1.5. And then B equals to 2. So equals to 2. And then C equals to 0.5. My C is here, equals to 0.5. Okay, and then my D equals to 4. So this one, D equals to 4. V equals to 0. So this one equals to 0. And then U equals to 1.5. Okay, done. So this is the sketch you need to provide during your test and also the final exam for the Simulink related question. Okay, so this one, done. Okay. Next, okay, when you run a simulation, you will get these results. Okay, so this one, you just use the block of the constant, and then you can annotate, you double click, then you can type U, then you can type constant and so on to complete all these example later. So this is manual calculation, how we solve from only the two equation given, which is this one and also this one, to finally to be the answer of this. So we actually solve part by part. I solve this part first, then I continue to solve the second part, which is this one. So you can see from here, the CX, which is this one, is related to the X over here. So that's why I use the gain block C multiplied with the X, then plus DV. You have to see the V is the input. So the D will become the multiplied, means the gain block. So you have to name this block as the gain. Okay, so you are expected to sketch this during your test and also the final exam. Okay, then this one done. Then example 4, 2-tank liquid system. Okay, this one we already solved using the method of transfer function. So I will go through again. I will go through again this one with, just now we already have the 2-tank in series, which is this one. Okay, so this one, the solution already provided, but you can see this is solved by transfer function method, where finally you have to solve using the chain rule, okay, to get the cascade side by side and use the transfer function block. So this is solved using transfer function method. Okay, so this is solved using transfer function method. Okay, for 2 tanks. Okay, in series. Okay, now with the same scenario, we are going to solve the two tank in series using the integration method. So this one, we will be solving using integration method. So solve using integration method. Okay. So integration method also will start with the mass balance. So you'll be having, like, for example, now this question, your U1 stands for the volumetric flow rate. Okay. So from here, they are using different letters. So let me check what is U stand for. U is the input. I believe it is the volumetric flow rate. Okay. So this is the inlet. So this is the inlet volumetric flow rate. This is also volumetric flow rate. This is the exit volumetric flow rate for the tank 1. And this is the exit volumetric flow rate for the tank 2. And this is also volumetric flow rate. So if we want to get the mass rate, it will be volumetric flow rate multiplied with the density. Okay, so for this question, you start with the same line, dm over dt equals to the mass rate in minus the mass rate out. So you expand rho equals to m per v, so your m equals to rho area multiplied with the height. So for tank 1, you'll be using rho a1 dh1 over dt. Okay, then you continue the same for the rest, but you are going to actually stop when you get the dh one side. You are not going to derive the steady state balance. So for the previous transfer function solution, right, you use the unsteady state minus steady state, then you Laplace transform both sides. So for integration method, you just need to proceed with the OD equation. So you'll be having equals rho, so U1, okay, minus the exit will be rho Q1. Then you stop. Your Q1 is the same equation where your Q1 here is H1 over the R1. Okay, so from here, you cancel the rho. You'll be getting A1 dH1 over dt equivalent to U1. So this one is a volumetric flow rate, minus H1 over R1. Okay, then you will having only dH1 over here. The rest you will move to the other side, meaning that you'll be having U1 minus H1 over the R1 bracket equivalent to dt. Then you'll be having 1 over A1. Then you integrate. So for their solution, you can see they're actually having, they multiply the A1 into the equation. Means they have U1 over the A1 minus H1 over the A1 R1. Then integrate dt bracket. Then after you integrate and derivative, right? So you'll be having H1. So for this tank 1, you already can sketch the diagram of this already, where this is the equal, right? So you start from here. Here is your H1. Then you have the integrator, 1 over the S, and you should label it, this one integrator. Then you're having the F block, 1 plus 1 minus, and you having, this is just like your 1 over the A1 gain, then multiplied with the U1, okay? So it is like multiplied. So this one, if I split, it will be 1 over the A1 multiplied with the U1, where U1 in this situation is actually an input. So input for inlet volume metric flow rate for tank 1, okay, which is this one. Okay, so from here, you need to include the gain block. So it is a plus, right? So go in plus again block to have 1 over the A1 and the input for your U1. And they should mention the U1 is step change. So you will need to have a block here, then put
This
the
is bromine.
U1 and label it as a step change or step input, also fine. Then you will be having this one solved, and this is H1. So your H1, so let me extend this line to longer a bit. So from here, go back. So this whole line is H1, and H1 is actually multiplied with this. Means you have 1 over A1 R1 multiplied with H1. Means this must be in the gain, multiplied. So when you go back here, if I want to put in the same direction, so I will having this one, 1 over A1 R1. And you should actually put asterisk like this, the multiplied symbol. Then you go in. Then already done the first part. So if you compare the answer over here, it is exactly the same. But you have to include like for example, they already say U2 is 0. So you just put U2 is 0. And then your 1 over A1. A1 is 1 multiplied with the R1. Your R1 is 0.5. So 1 over 0.5 will give you the answer of 2. Okay, so you can include this one inside as a 2 also fine. Okay, and then the rest will be initial condition. You remember here, we have to put the H at time equals to 0. So they will give you the information for the H1 at time equals to 0. So like this, initial level for the tank 1 is given as 0. So if you use the Simulink, you remember you right click, you double click this integrator block, then you change the internal to external. So change to external. Then you're able to put the value of the initial condition of the level. So if you sketch, then you just need to having another arrow going in and put the initial value of the level as a H1, then bracket 0. So this means it is the initial level for the tank 1, and it is given here equals to 0. Okay, the level is 0, means the tank is empty lah. Okay, and then we will continue with the tank 2, dH2 over dt equals to this. So you will continue with dH2 over dt. So how you get this line? Okay, you repeat everything the same for your tank 2. So I put it here. This one is tank 1. So this one is tank 2. So repeat everything the same, dm2 over dt equal to mass rate in minus mass rate out. So you'll focus on the tank 2 over here. The one going in is your Q1. So you'll be having rho Q1 minus rho. The one going out is your Q2. And you have another inlet over here, which is your U2. So it's plus rho U2. There are two inlets going in, then minus rho, one exit, so Q2. Okay, expand this one, rho A2 dH2 over dt. Then cancel your density. You'll be having A2 dH2 over dt equivalent to Q1 plus U2 minus Q2. And they will tell you the initial level of the tank 2 also 0. And then the R value. R2 is 2 over the 3. And then your A1, or just now this one, you have to sub. Okay, 1 over the 1 will be equals to 1. Because your A1 is 1. So the rest, I think, complete. And then for this U2, right, it is a value of 0. So this U2 is a 0. 0 is a constant. So you should include constant block. And your initial level for the tank 2 is also 0. Okay, now you can complete this your R2 is 2 over the 3. So from here, you will replace this with the H2 over the R2. So you're having A2 dH2 over the dt equivalent to Q1 plus U2 minus H2 over the R2. Okay, then you will just keep the dH2 over here. The rest will move to the other side. Means Q1 over A2, U2 over A2 minus H2 over A2 R2, then bracket dt, integrate. So once you have this, integrate both sides, this will give you H2. Okay, if you continue from here, you remember what is your Q1? Your Q1 is H1 over R1. So this is your Q1, H1 over R1. So from here, your Q1 is H1 over R1. Means this whole thing is actually H1 over the A2 multiplied with the R1. So H1 is here, right? Meaning that 1 over A2 R1 is your gain because it's multiplied with your H1. So you must be having the gain block over here to have 1 over A2 R1 multiplied with the H1. So this one is actually your Q1 over the A1. So you can see the solution, they actually having the 1 over the A2 here. So you'll be having the H1 connected to 1 over the A2 R1. So H1, where's the H1? So H1 is here. So 1 over the A2 R1. Okay. So you will multiply. Then you sub in the value. What is the value of the A2? The A2 is 0.5. And then your R1 is 0.5. Okay. So your R1 is 0.5 and then your A2 is 0.5. And this will give you the answer. I think this one maybe they calculate wrong already, maybe later. So it's 1 over 0.5, then divide by 0.5. Yeah, correct. So this one should give you 4. So this one equivalent to 4. So in your solution, you should able to include 1 over A2 R1. Then you do some calculation over here and equals to 4. Okay, so we already solved this part. This part. Okay, then you having the you will be having something you start from the back. So I remove this. So you'll be having H. So I will put some solution here so that you can relate. So you'll be having H1 over A2 R1 equivalent to 1 over A2 R1 multiplied with the H1. That's why when multiplied, you will solve using the gain, which means you will link to this. Okay, and then you are having something similar. You will be having the last as a H2 like this. Okay, then you need to present your outcome in the form of scope. Okay, now integrator block, the same one. So you put integrator, and integrator having the input for the tank level H2 at time equals to 0, and the value given it is 0. Okay, so the one going in, so now you have plus, plus, minus. So you're having plus, plus, minus. So you'll be having a add block plus, plus, minus. So the one plus you already solved just now. So you go in here, plus. So the second one is also gain block. So 1 over the A2 multiplied with the U2. So you'll be having this one going in, triangle, 1 over the A2, and the input is U2. And this U2, they already mentioned over here, it is a number of 0. So you should equal 0. And then label this block as constant, label this block as gain. So 1 over A2 means 1 over your A2 is 0.5. So this will give you 2. So that's why you will get the answer of 2 over here. Okay, so this one is 2. And then the last one is another minus. So you see this minus. So this one also the same thing. You'll be having a gain 1 over A2 R2 gain, and then your output H2. So you'll be having your output H2 over here go to the negative. So you can put in this direction also the same thing, 1 over A2 R2, and this whole thing will go into your negative. So 1 over A2, your A2 is 0.5, and then your R2 is 2 over the 3. So this will give you 0.5 times 2 divided by 3. Okay, 0.2 is 0.5 times 2 divided by 3. 1 over the answer. So this one will give you the answer of 3. So equivalent to 3, which is having so the mistake I think from so just now you're having 1 over the A2 R2. Let me double check. A2 is 0.5. R2 is 2 over the 3. 0.5 times 2 divided by 3. 1 over the answer. So it is answer of 3. So not 2.94. So this one, mistake. So this one should be 3. Okay. So this one should be 3, not 2.94. Okay. Then you already complete all this. So you must able to sketch this, okay, manually for your test 1 preparation. And then your homework is to combine everything using the Simulink, screenshot and submit to the My Time Stamp. So you can see when we combine everything here, so this one error, this one should be 3. So you'll be doing for the tank 1, and then this is the tank 2. So refer to the recording if it is too fast. You are expected to solve this either using transfer function block, like the previous section 12 p.m., or using the integration method. So I have demonstrated 2 solutions for the same questions. So either you solve using the transfer function, or either you solve using the integration block. Okay, so I will stop sharing. So this one done already, so stop sharing. So for your preparation, okay, I share already. Okay, so for your preparation of your test, the topics will actually cover from week 1 until today. So either you are sketch, you are asked to sketch for the first order, or maybe the first order with transport delay, or solve using the integration method, or you solve using the transfer function method, and all the calculation to support manual calculation. So you can ignore for your test 1. I do not include the heavy side in your test 1. So there will be only one time of change for your input. So the heavy side, I will definitely include in your final as the scope. Maybe it is not there, but it will be in the scope of the final. You will need that for your final exam only. So for your test, you don't need to focus much on the heavy side, and also the linearization. You remember we have the Taylor series linearization, where we actually having the example of Q equals to CH power to 1 over the 8, one of the example, where your H, it is not power to 1. Then you have to use the Taylor series expansion to linearize the equation. For example, the one we have it here. So last, we have the, let me show you the appendix. So I will show you the appendix of the test. Let me search a while. Cannot find. Wait, okay. So your test. Okay, share. So you'll be having this simple list of equation. Like for example, the one you can score full marks will be the second order dynamic behavior, where you are requested to calculate the overshoot using the equation. So this equation will be given, but the equation for the overshoot, for example, overshoot is actually B over the, A over the B. So that one you have to memorize overshoot equation. The equation of this is given in the appendix, like the second order transfer function also given. So you please focus on the tutorial, ask you to calculate the period oscillation, the overshoot, the decay ratio, and so on. And for one of the simple method in the previous tutorial that we're actually having a higher order model that you approximate using the Scott-Jess half rule and Taylor series expansion. So we have plenty of examples to cover for Scott-Jess method and Taylor series expansion. So these two equations are given to you to start. Like for example, for the top, you are going to use 1 minus theta s. For the rest, you have to do the expansion and have the pattern of this. So go through the tutorials again. There will be one of the questions talking about the Scott-Jess method and Taylor series expansion. Either you approximate the model into first order with time delay or second order with time delay using the Scott-Jess half rule or using the Taylor series expansion. So the one I talk about, the Taylor series expansion, is the one that we have in our tutorial. I can't remember. Let me check the tutorial. So now Taylor series expansion, if I'm not mistaken, will be this one. 4. Okay, so this tutorial 4, you need to focus. Okay, or this like A over the B. You need to memorize this. Decay ratio is C over the A. So tutorial 4 is the star tutorial for you to score one of the question full marks. How you solve the rise time and so on. So refer to this. You all refers to the handwritten solution I shared in the Telegram. So for all the week until now, week 6 already, all the handwritten notes already shared to Telegram. So the other one is the 3, where you can ignore the solution of the heaviside. So this is the heaviside solution for question for this one. Okay, so this is the heaviside Q3. For 2 types of changes where the thermometer is firstly placed in the first water bath and then put in the second water bath. So this one, no time actually for you to solve during the test because test only 10%. So I remove from your test, but you need to focus this one during your final exam. Okay, the other one, like heaviside, is not included in your test. And the other one, linearization. Okay, linearization will be, I think another one is 2. Okay, this one. So linearization is this example where you can see one of the control variable, it is not power to 1, where we use the Taylor series expansion to solve. So this one is tutorial 2, which I do not include in your test 1 as well. So you don't need to have this one in your revision, but I will include this as one of the scope for your final exam. You will need this during your final exam. So you can put a star there. This one is for FE, final exam, not for test 1. Okay, and for Q3, heaviside is not in your test 1, but it will be in your final. Okay, so, and then for your test, this is the star question, tutorial 4. Make sure you repeat your tutorial 4. And then one more will be, I think no more already. Tutorial 1 also have to repeat. Please try to do. Okay. Yes, and this is tutorial 4, right? So this also the star question. I do not solve using this method, but I solve, you refer to the handwritten solution that I already shared in the Telegram. I actually expand this to become k multiplied with negative 0.3 plus 1 multiplied with 1 over 1 plus 7s multiplied with 1 over 1 plus 4s multiplied with 1 over 1 plus 0.4s. So the one at the bottom, you have to arrange from the highest tau to the lowest tau. Okay, so if I'm too fast, you refer to the recording, then you jot down the notes that you have to take note for the test and also the final exam. So that's all. It's a quick briefing for your test. So please spend some time for revision. The test is actually 10 marks covering the topic from week 1 until week 6. We can exclude the heavy side and also the long calculation, which is this one, the linearization. So you can exclude the linearization, which is this one, okay, using the equation of ht minus c, ft minus c, but this one will be in your final, okay? So, and also focus on the approximation of the higher order, like the last question of this, and also the sketch of whatever you have learned this week or last week, like you're able to actually solve the manual calculation like this and proceed with the sketch. So all this will be in your test one. Okay, that's all. Okay, done. So I will stop sharing, stop recording. Thank you very much. Hey, no. You have to take your attendance. Attendance. Don't leave. So attendance, share the screen again. Always forget. Okay. Okay, please mark your attendance here. So after the test, I will remove all the recordings. If you want to save, then you can save for your own usage, but don't share with others. Don't share with your junior. Just keep for yourself for all this recording if you want to save. For the revision of the final exam later, maybe. Okay, so that's all. Done 12. Okay, some absent. So Edmund is here. Hashini, Junhan, Shri, Raymond, Shabish, Davin, Pavindra. Okay, that's all. Thank you. Bye-bye.